I was asked to give a little bit of background while you're here and the importance of being here for a family with a loved one who has type 1 diabetes. So it's all started by the consulate of Sweden in Los Angeles contacting me when I was at University of Washington to do a Beyond Blonde drive to get people to work with the Swedes. You know, Volvo is owned by the Chinese, Saab is dead, IKEA has its main headquarters in Holland. So there wasn't much left. So we then build on the awareness of type 1 diabetes because it was clear, and it's still a problem, that people think about type 1 as type 2. They don't see the difference. They think childhood diabetes is growing away as you get older, etc. So I'm very pleased that this has developed into a necessity for you. And we had voices of what happened during our first meetings from participants. And Pat Cashman was our MC at the time. And, you know, overview of the latest research with time for questions after each presentation. Something very important for you to know, that you can ask questions when the speakers are here. And getting the details of the specific studies that JDRF supports, and hearing an update of type 1 care and management from the leaders in the field. So that was really what we were able to accomplish. And it was based on the notion also working here that Seattle greater area has as much type 1 diabetes as we have in Sweden. This is my commute from Seattle to Copenhagen. Malmoe is across the street. These are the different hours when we were passing different places on the earth. So Seattle is up to around 30 new children per 100,000 children per year. Sweden is 60. Finland up here is even higher. So it's almost as much diabetes here as back in Scandinavia. And why is that? Why is that? Well, this is a map. This is United States. You see that? And the red dots is names of farms, villages with Swedish names. The green dots are Swedish names on lakes, rivers, parks. So you see this, there's a little group of Swedes up here. Minnesota, no surprise. Bachelor farmers. And then look at this. Where is that? It's here. And why is it that the risk of developing type 1 diabetes is so high here? It's the Scandinavian influx. This is the Scandinavian peninsula 9,000 years ago. This is the inland ice. The black arrows are the people moving in after the animals to hunt them when the ice was melting, okay? So these people, how did they survive? They brought their own diseases, of course. So there is a system that's called HLA, which is the genes controlling the way we are fighting infections. This is our survival proteins and genes. If you are HLA-DR4, which is 18% of the Swedish population, you are a tuberculosis survivor. Remember, 10,000 years ago, how much penicillin did they have? 0, right? HLA-DR3, 16% of the population, measles survivors. So then when the Europeans are coming to North America, they bring all these diseases with them. So the natives living here, coming from Asia 30,000 years ago, they don't have DR3. So when there was a measles outbreak, they died, okay? There was no way for a native to be able to fight that infection. But the Scandinavians could. Healthy looking to be 10,000 years ago. So HLA is sorting population based on susceptibility and resistance to infections. And this is where the immune system comes in. The beta cell has fever, infected with a virus. It's eaten by a scavenger cell, signaling to the T helper cell, who has two students. The B cell makes antibodies, the killer cells kill the infected cell. This is our way of surviving. The problem is when you get type 1 diabetes, you have T cells, the killer cell, killing beta cells. That's the primary way we are losing beta cells in type 1 diabetes. The antibody producing, the blue guys, are blowing out antibodies against GAD, IA2, insulin, and zinc T8, 4 different autoantigens. These autoantigens, these proteins, are all inside the beta cell. So the antibodies are circulating in your blood empty. And you see these little antibodies that they have nothing in their mouth because the autoantigen is inside the beta cell, and they become warning signals that there are red killer cells around. So in the TEDdy study, we selected these genotypes, as they are called. The immigrants brought DR3-DQ2, high risk for GAD, as the first autoantibody. The DR4-DQ8, high risk for insulin, as the first autoantibody. So here again, what happened in type 1, sick beta cell up at panel A, and then signaling to the T helper cell at panel B, and it's a GAD fragment that is given to the T helper cell, who is telling his two students to attack where GAD is. And GAD is shown up on the beta cell surface as a fragment that the killer cell will find, and in this way kill the beta cell. So green fragment, green sword, dead beta cell. So in TEDdy study, we have found that the first autoantibody to show up if you're DR4-DQ8 is insulin autoantibodies. And we did not know that they will come so early as they did. So you see the red peak is 1 year of age. That's when the first insulin autoantibody showed up. The blue line is the first GAD autoantibody, and the green line is those children who had 2 autoantibodies at the same time. So these are 2 different diseases. You either start your type 1 getting insulin autoantibodies first, and then you get other antibodies, and eventually you develop diabetes. Or you start your disease having GAD as the first autoantibody, and then you get others and eventually develop the disease. And you can see it's about GAD as the first is 40%, insulin as the first is 39%, and 13% are having 2, and the other antigens are not that common. So this is the upshot of developing 1 autoantibody. 10 out of 100 are going to develop diabetes within 20 years. 2, the blue line, 2 autoantibodies, diabetes, almost 70 to 80% in 15 to 20 years. 3 autoantibodies, we think that everyone is going to get the disease. And it's understandable. If you have 4 of those red guys killing beta cells, the progression to diabetes goes faster. So what to do now? We have to figure out what the triggers are. It's either insulin in the DR4-DQ8 children or GAD in the DR3-DQ2. And we want to treat them in a way that their immune system is not going to look at the beta cells as foreign. It's not going to look at insulin as a foreign antigen, not going to look at GAD as a foreign antigen. So if you think research is expensive, try disease. And that was Mary Lasker who said that. And there is research in people, in humans is expensive, but there is no alternative. There's no way around it. Controlled clinical studies are needed. You're going to hear much more about that. We need smarter design, faster studies to move ahead. The research subjects, you people participating in TrialNet studies, are remarkable. This girl has 3 autoantibodies, and you can see the number of blood samples that she's donating for research in the morning when she's doing an intravenous glucose tolerance test. And in the TEDdy study, the Swedish children in January had donated 1 million test tubes, stool samples, blood samples, urinary samples. So have a great summit. You're going to have outstanding speakers. You should pick their brains. Thank you.
I feel like my mission moment should really just be, let me pass around my CGM to you all and show you what a pretty awful morning I've had so far. So I'm really here to talk about the artificial pancreas update. You know, for the last probably 6 years, you've been hearing about this idea of an artificial pancreas. So I wanted to give you a little bit of an update on where we are and where we're moving forward with, and why is this so important. I know there's a lot of messages out there saying a lot of different things. So first of all, the Artificial Pancreas Project was started in 2006 by JDRF, and they had a very simple mission, however, a very ambitious mission, and that goal was to essentially take existing technologies that were ever-changing, insulin pumps and continuous glucose monitors, and insulin, a drug that can be deadly if not used appropriately. And they just wanted to do a simple thing of, let's put together a bunch of scientists and let's put together this existing technology and let's put that together on people and let that function as closely as possible to human pancreas. No big deal. No big deal, right? So where are we today? For those of you that don't know, we have made a tremendous step forward in the progress to a completely closed-loop artificial pancreas, and I don't think it can be understated how impactful and how amazing this step forward is. So I'm proud to announce, and as many of you know in this room, so is this new to anybody? Raise your hand if this is new to you. That of September 28th, no one? All right, September 28th. Medtronic, the FDA, approved the first hybrid closed-loop system. So, yeah, I know, I'm seeing a lot of... So my mission moment needs to be, and I'll be very frank with you all, this morning I woke up, my blood sugar wasn't too bad, but it's definitely, that's not great. I don't know what happened this morning, normal morning, I speak quite a bit. As of about 10 minutes ago, I was 340. I've been, feels real good, but I've just been watching my blood sugar creep and thinking, if only. So I do want to talk about a little practical, what does this system currently do? And you obviously can go speak to Medtronic, but I think it's good to just get a general sense right now when we're talking through this. So obviously the system is meant to launch in the spring of 2017. That means in your hands. And it's really the first system that's going to automate basal insulin delivery, which essentially what I needed this morning. You're increasing that basal delivery when glucose is going high, like up to 340, yay. But also decrease your basal when it sees that your blood sugar is going low. Yes, users at this juncture are still going to have to bolus. They're still going to have to prompt the system when things are happening. But what have we seen in the pivotal study results? I think this is where we get excited. Yes, you're still having to interact. Yes, you're having to function with this pump. But when you look at things like this, and for me, 44% less time spent with low glucose, how many of you would really, really, really enjoy maybe only setting one alarm in the middle of the night instead of 3? I think that is a drastic decrease. For me, I would love it if I could exercise without having to do a 3-hour activity of put a temp basal rate on. Do I need to eat a snack today? What's going on with my body? Okay, I can exercise. Oh, now I have to drink 7 juice boxes while I'm exercising. So you look at some of these things, and again, you can find much more details on this or speak with Medtronic, but I did just want to give you a sense of what came out of that study. So I think in addition to clearly this being a tremendous advancement and a huge step forward as we move towards the ultimate goal of a fully closed loop artificial pancreas, there's two things I wanted to point out that you may not necessarily think about when you're thinking about this, because we focus on what does this mean for me. But I wanted to talk two things. First, the power of collaboration. I think it's incredible to look across how many people were involved in this and different types of people. So we're talking about industry, we're talking about government, we're talking about research institutions, we're talking about funders. All of these people came together with a common goal, which is not often and easily done, to push this forward. And so the other equation to all of that, I'm going to ask you all a few questions. How many of you have fundraised and asked people to give money to JDRF? Keep your hand up. How many of you have volunteered for JDRF? Keep your hand up, all of you, everybody. Don't put your hand down. How many of you have donated yourselves to JDRF? How many of you have educated a family member, gone to a school, talked to friends about what type 1 diabetes is? How many, yeah, that should get everybody in. And how many of you wrote to a government agency and said, this is important to me, I need you to fund this? How many of you are a JDRF advocate? That is why my second point is, it is beyond incredible how quickly, the speed at which we went from bench, where we're talking about research, just not even on humans, just in bench, of an artificial pancreas, to being in the hands of people in 2017. From the start of this, I'll give you a few dates. In 2009, Aaron Kowalski, everybody knows Aaron, very wonderful, tremendous person at JDRF. He developed a 6-step roadmap for the artificial pancreas. 3 years later, the first outpatient trial was approved by the FDA. 3 years after that, so just in 2016, June of 2016, 3 years later, Medtronic went to the FDA with their pivotal trial and said, we are ready to take this to people. How many months later did the FDA turn around and say, yes? Just under 4 months. And that is 100% because of that collaboration, because of all of your funding, your fundraising, your communication to people, your pushing forward. You're driving these people, the government, we're driving industry, we're driving other funders, you're driving advocacy to one common goal. And in 10 years' time, we went from a lab to humans, which is exceptional. So I had mixed feelings about this. I was incredibly excited, but there's a but. And I felt like I was reading through a lot of things to prepare for this, and I saw a quote from JDRF CEO Derek Rapp, and he said, this announcement is a historic achievement for JDRF. After years of laying the groundwork, this breakthrough is a testament to the reason JDRF exists, to help people with T1D lead better, safer, healthier lives. This is where the wheels fall off for me. I'll try to keep it together. That's a picture of my dad, and he was about my age, actually, in that picture, about 35 years old. When my father was diagnosed with type 1 diabetes, I'll back it up. Our story, the story of my father and I, you both know that we were diagnosed with type 1 diabetes, really doesn't demonstrate any better how important it is that we focus on helping people with type 1 diabetes lead better, safer, and healthier lives. I'll get to the but in a moment. When my father was diagnosed, not even continuous glucose monitors, glucometers didn't exist. Imagine not ever knowing your blood sugar, not knowing your child's blood sugar. Imagine when you go to inject your child with insulin, you have to boil a glass vial, screw on that needle. Can you imagine how giant a needle is to screw it on? Sharpen it with a pumice stone, and then inject them with some insulin that is going to peak maybe in 5 hours. That insulin may peak in 10 hours. You have no idea. And you also don't know exactly what that insulin is doing to their blood sugars. That was the reality when my father was diagnosed. So consequently, at age 35, in this photo, he was technically legally blind. He was undergoing laser treatments. At age 40, he had a kidney transplant. At age 55, he had a near-fatal heart attack. A year later, his first leg was amputated. A year after that, his second leg was amputated. And at age 58, I was almost there, he passed away, all from complications of type 1 diabetes. So when we talk about the importance of continuing to push these efforts forward, all you people crying in the audience are not helping me. when we talk about the efforts of pushing things like technology forward, it is beyond imperative. But here's my but. There's a but. And Derek Rapp, the CEO of JDRF, recognized this, that the artificial pancreas is not a cure. And for a number of us, I cannot overstate the importance of moving forward with technology and helping our lives be better, but this is not a cure. And I still worry about the possibility of my friends and my family developing type 1 diabetes. And so that's why I love this line at the end. While we continue on the path to cure and prevent the disease altogether, we are not going to stop moving forward with technologies and making life better and easier. And we're absolutely not going to stop moving forward with preventing and curing type 1 diabetes. So, So for me, I found this incredibly motivating. It was like, here is this thing that we outlined, that JDRF said, we want to do this. And they outlined a plan, and they said, we need your help. And we came together, and we gave the support that we could give, and look what we accomplished. So I get goosebumps when I think about it, that now the next, what's going to happen in the next 10 years for us when we have that same power, which is why I'm going to continue to do more. I'm going to continue to give more. I got on a bicycle for the first time in like 19 years the other day, and it was atrocious. But I'm going to continue because I want to do Amelia Island ride. I'm going to volunteer more. I'm going to ask more. But I'm going to do this with such renewed hope and excitement for what's coming. So my last thing is to just say thank you. This is some of my family members, some of my type 1 diabetes friends. Thank you all. For doing what you do, for being here today. I can't tell you and stress to you enough as a layperson, a person with type 1 diabetes, the speakers that we have here today, and actually what you're going to be learning from talking about from here forth really is about that cure and prevention with Dr. Greenbaum, Dr. Buckner, and Dr. David. You're going to learn a tremendous amount about that. But this is the coolest part ever. You have access to world-renowned researchers. I'm a layperson, and every day I walk in a door and I get to work with these people and talk to them. And they are like my all-stars. And we have access to these people, and they're here in Seattle. It's incredible. I want to encourage you to take time to ask them questions, to stop them in the hallway. Feel free to hug them. They might not appreciate that, but tell them thank you. But ask them questions, and hopefully you feel as hopeful and excited as I do after your day today. And thank you so much. And I will pass it over to Carla.